Let me discuss about the serial communication. Serial communication is used to send and receive the data in serial form, that is bit by bit form. See here, this 8051 microcontroller have two pins especially for serial communication. One is transmit, another one receive pin. And this is for connecting to the RS to the 32 cable intern to the system or any other device you can connect. So this max 232 is to use as a level shifter because the voltage levels, the RS to the 32 cable is different from the voltage levels of the 8051 microcontroller. So now let us see, the serial is nothing but is a one wire, the sender and the said receiver. Parallel means you see more number of wires are required, like number of bits equal to number of wires required. So these are the few examples of the serial communication protocols used practically. There is I2C, RS-232, USB, RS-422, CAN, microwire, RS-485, SPI. Now, for your syllabus only, that is UART. Just by using RS-232, we can transfer the data. This is the cable, RS-232 cable. One side is male, another side is female. So here, the RS-232 connections are. So only three are sufficient to transfer the data. Actually, it is called DB9, 9-pin connector. So the other pins are required to for handshaking signals. So that is not compulsory. If it is very important data to be transferred, so then we are going to use for handshake signals. Next. So programming, here for programming, as you know that similar as for timer, here also clock is 11.0592 megahertz is used. And there in timer only it is divided by 12, but here once again it is divided by 32 before applying the clock input for this UART. UART is a universal asynchronous receiver and transmitter. This device is going inside, it will be a part of the 805 microcontroller, the serial communication device. It is going to frame the data. You have to configure and any data to be sent in serial form by using SCON register. You have to configure and send to SBuffer register. This UART will take care of those things. So you have to set the baud rate, the number of bits per second, the data transmission speed we need to set. So this actually it is we need, for example, 9600 is the standard baud rate. Then the available, the clock, it is 28,800. But we need 9600, we have to divide by 3. This operation we are going to perform with the help of timer 1 in mode 2, auto reload mode we are going to use. So we are going to load the value 253 into H1 register and make it auto reload and start the timer. It is going to generate. I mean, it is going to divide by 3 operation can be done in timer, in timing multiplied by 3. That is equivalent to divided by 3 in frequency. So here SBuffer register, anything to be transferred, first you load into SBuffer register, the data to be transferred in serial form. Then SCON register for the control register for configuring the serial communication device. So here we are using 01, it is the most popular mode, 8-bit UART with timer 1 determined baud rate. We are using timer 1 to configure the baud rate. So is normally mode 1 is use 8-bit, 8 data bits, 1 start bit and a stop bit, like this. 1 start bit, then 8 data bits and 1 stop bit. This will be for format will be done by UART. Just you have to configure using SCON register and load into SBuffer register. So this is how, as I told, clock frequency is the main clock frequency divided by 12 and divided by 32. So it is for timer 1, so that in turn is going to generate the baud rate 9600. So this is what FD. FD is nothing but the timer has to loading the 253 number in decimal, that is in hexadecimal is FD. So we are generating 9600 baud rate here. See, so set a 9600 baud rate divided by 3. Minus 3 is nothing but converted to FD. Then here T mod timer 1 in mode 2. So TH1 is loaded and start the timer. It is going to generate the baud rate. So to send a data in serial form, as you know that we need to set the baud rate by using timer 1, mode 2, auto reload, and SCON register set the mode 1, that is 8 bits, one start bit and stop bit. By loading the value into SCON register, 50 we are going to load like in SCON register. See here, SCON register, serial control register, here mode 1. This is here SM0, 0, 1, 0, 1, and this is 0, and this is 1. So it becomes 5, and these all remaining will be zeros, 50 we are going to get. So 50 we are going to load into SCON register, 50, and start the timer to generate the baud rate. Then the data to be transferred in serial form, that you have to load into SBuffer register. Then you have to wait till it all data bits has been transferred. Whenever the stop bit will be sent, then your TF flag become, TI, transmit interrupt flag become 1. See, let us see here how to transfer the data. For example, character D, you want to transfer in serial form. First, you have to set the T mod, timer mode register, timer 1 mode 2 to generate the baud rate. So TH1, you have to load the value, that is FD, means 3 times. After 3 times overflow should occur. And SCON, 8 bit, 1 stop bit, 1 start bit, and receiver enabled. So these in SCON register will get 50 number. So that you will have to load it to SCON register and start the timer to generate the baud rate. Then you have to send the data to be transferred in serial form into SBuffer register. So then you have to wait, you have to check, is it all bits has been transferred? At the last bit is a stop bit. One stop bit will be sent, then this TI flag become 1, then clear the TI flag, then you jump again, once again, continuously you are sending the D in serial form. Okay, the similar same procedure. There is an embedded C also, you can write the same procedure. Some different baud rate also you can set by changing the values of timer register. So this is about the serial communication. Next, let us an interrupt, try to understand what is the interrupt. Interrupt is nothing but to execute more than one task at a time to make parallel functioning instead of waiting. See, one device, for example, it is going to get the data from some satellite. So the time is not fixed. Until the data is available, the processor should not be idle. It has to do its own function. Whenever data available in that input device, it will send one signal to the processor. Then it will stop its function to read the data. So in such case, we can save a lot of time and make the processor will be efficient so that it will execute more than one task at a time. So that is the purpose of interrupts. So let us see what are the different types of interrupts. An interrupt is an event that occurs randomly in the flow of continuity. It is just like a call when you are busy with some work, and depending upon call priority, you decide whether to attend or neglect. Similar concept. Similar way, interrupt also. Whenever processor is working, So it will receive the interrupt. It may service or provide service or may not, depends upon its priority, its status is enabled or not, or maskable or not, like, okay. The same thing happens in microcontroller. 5 interrupt sources, out of which 2 are the internal timer interrupts, 2 are external one is serial interrupt. So each of these interrupts has its interrupt vector address, means whenever an interrupt occurs, it will go to a particular address. The highest priority is reset, means it will go to 0 whenever a reset occurs. See here, the interrupt, its vector addresses, when reset occurs, it will go to 0 memory location. When external interrupt IIT 0 occur, then it will go to 003. Timer 0 occur, means it will go to 00B. Then external interrupt 1 occur, it will go to 0013. Timer 1, it will go to 001B memory location. Serial, any serial that is transmit or receive, then it interrupt generate, then it will go to 0023 memory location. These are all in hexadecimal. So these are in detail about interrupt enable register. So the particular timer can be enabled. The for any interrupt to be enabled, this interrupt enable all bits should be 1. Then this bit 4 is for serial enable. 1 means enabled. If it is enabled, then only it could be able to provide the service by the controller. Otherwise, simply it will ignore. So then bit 3 is for timer 1. This is for timer 1 enable. Then this is for external interrupt. This is for timer 0, external 0. Priority also, these are in the priority, default priority. These are, you can change the priority by using interrupt priority register. You can change it. So external, you can low level triggered or falling edge triggered. You can make it by using this recount register. Corresponding bits you can make it a 1, so that either you can make it as edge trigger or you can make it as a low level triggered. Okay, this we'll see in the next class.